In this video, I'm going to be fixing this toy. Hey everybody, it's Adrian from Zanza's Toys, and in this video, I'm going to be doing a toy repair. So recently, I went to Daiso, this awesome Japanese dollar store, and I got a bunch of these. So these, fruits and vegetables that come apart. And I think this is just a great example of the toy maker's art. It's a really simple kind of toy, but one with a lot of play value and that mimics the real world in a really fun way. So the Velcro is cheap and safe. Not only does it hold the pieces together, but it also provides a nice crunch when you cut through it, like that, which is just great, right? It's really great toys. But one of them broke. So here's half of the tomato, and it got caught underneath a door and snapped. So I'm going to fix this. I could just throw it away. I mean, it was very inexpensive. It was $1.50 for a set of 4 vegetables, a little knife, and a cutting board. But why throw it away, right? I can fix this, so I will fix it. What I'm going to do is I'm going to use a 3D printing pen to weld these two pieces back together with a little bit of filament. So it'll be good as new. Let's get to it.
So the first thing I had to do was to get my 3D printing pen out. I got this pen for like $10 on eBay, and I really, really like it. It's much thinner than most 3D printing pens, and it has this really nice LED display. Let's just set it for ABS or PLA. Next up, I had to decide on which filament I wanted to use. So I kind of got out my various reds and compared them to the plastic of the toy. And then once I had settled, I had set up my pen, which it turns out I had left some black filament in the pen, so I had to push all of that out. So that took a while to just clear out all the black filament and get the red filament flowing. Then I was ready to actually get started. So welding plastic is a lot like welding metal in that the actual welding is only about 1/3. There's the first third, which is cleaning and setup, the second third, which is the welding, and then the third third, which is cleaning up after the weld. So in order to do some prep, what I wanted to do is a couple of things. I wanted to start by putting some plastic behind the piece that had broken off, so that I could have something to press against, so the piece wouldn't just push into the cavity of the toy. And I also wanted to go along the edge and kind of shave it down a little bit, and the reason I did that was to get better penetration. So when you're welding metal, you don't want surfaces to butt against each other in a flush manner. What you actually want is kind of like a V-shaped slot, so that the new material that you're adding as part of the weld can penetrate. It can get into and bond really well with both of the parts you're trying to weld together. And all that applies to plastic as well. So I was sure to go along the entire edge that I was going to be welding together and shave off a little bit so I'd get a nice V-shaped groove to weld my two parts together. I did the same thing for the part I was going to join, just shave the edge a little bit, and I was ready to start welding. So just like with welding metal, I didn't want to just go along the entire seam. What I did instead was weld a little bit on one side, and then I welded a little bit on the opposite side. That way I could make sure everything was nice and aligned. If I had started welding from one edge all the way across, it's possible that misalignment could have built up over the course of the weld and given me a less good final result. So once I had it all tacked down, I just went along and welded the two parts together, pressing with the pen and making tiny little circles just like you would with a MIG machine for welding metal. I definitely ended up with a lot of extra plastic, but that's kind of the point. What you want to do is make sure that you get good penetration between your two parts. If that ends up with extra, that's fine, because realistically, again, the whole third of any welding operation is cleaning up the weld once it's there. Okay, so I had the whole crack welded together, but then I decided to go ahead and weld the front face too, at least a little bit, at least where the part had broken off. Here, there was already a little bit of a gap, so that let me get good penetration without shaving anything down. Okay, so at this point, I had everything welded together, but I had all this unsightly mess of extra plastic. Now it was time to clean things up. To do that, I started by just using a blade to kind of shave off as much plastic as I could. This definitely took longer than the actual welding, but again, that's one way in which this is just like, at least my experience with welding metal. Very often, the cleanup will take at least as long, if not significantly longer sometimes, than the welding itself. My first job in California when I first moved out here was at a welding shop, and I guarantee that the number 2 tool that we used on a daily basis, number 1 being our actual MIG welding machines, but number 2 was definitely our grinders. Overall process to almost everything we did there was setup, which would take a lot of time, but always pays off. The more time you invest in good setup, the better your weld is. Then weld, then cleanup. And usually what we would do is we would have one grinder set up with a normal grinding wheel, and then we'd have another grinder set up with what we called a flapper wheel. So the grinder would let us get the metal flat, and then if we needed a nicer finish, we would use the flapper wheel to get a really nice sort of polished, almost brushed look. We didn't do that for every weld, but as needed. So in this case, my sort of the equivalent of my normal grinder is the blade that I was using to just remove a bunch of material. And then the equivalent of the flapper wheel, as we called it, is a small file. Once I had the big chunks cut off, I just got to work with my file to sand things down to make it nice and both remove some of the extra material and also make sure it was nice and smooth so there's nothing to cut my son when he plays with this. Don't want any little toddler fingers getting hurt. And this went on for a while, just sanding. My goal definitely wasn't to get it completely flush. I knew I wasn't going to get it to the point where you couldn't see the repair, but I don't really mind that for two reasons. One, you actually see lines kind of like this on some tomatoes. If you get like a really juicy, slightly overripe tomato, you'll often see lines that look not too dissimilar to the kind of sort of squiggly line that we're left with. And then there's also this concept of wabi-sabi, where there's this Japanese practice of repairing things but highlighting that they were repaired. And I think there's something kind of beautiful about that. So I think this toy showing very directly that it was repaired is honestly kind of a nice thing, and I sort of enjoy that. Or maybe I'm just rationalizing. You can be the judge. And then I was done, and the tomato was repaired.
So that's about it. Just a quick video with a toy repair, and we have one almost as good as new tomato half now. You know, you can still see the repair, and I think that's actually fine. I think it's a certain amount of charm. So I don't expect this to last forever, but it'll last at least a while longer, and my son will get some more fun playing with it. Yeah, I mean, I definitely spent more than $1.50's worth of my time doing this, but I actually really enjoy repairing things and taking something that would have been thrown away and kind of bringing it back to life, or breathing new life into it. I really enjoyed doing it. I hope you enjoyed watching it, and if you want to see more videos on toy design, toy making, toy repairs, please don't forget to like, comment, and subscribe. Thanks so much. I'll see you next time.